Hello and welcome back. Today we're going to return to bond valuation once again. We're going to look at two problems. One has to do with the calculation of bond prices using spot rates, and the other has to do with the calculation of a bond's price given a market discount rate. With that, let's get started. So here we're given a spot rate curve table, a bond's coupon rate, and we're told it's 18 months to maturity. So immediately we can discard the 2-year rate. Now each of these rates is on a bond equivalent yield basis. So we divide by 2 to get the effective 6 monthly rates. We can draw a quick timeline and plot out the payments that are due from the bond. Because it's a 9% semi-annual coupon and a $1,000 face value, we have a $45 coupon payment. And of course the final payment, which is 3 periods out, is $1,045. So we can compute the present value or fair value of this set of cash flows by applying the appropriate rates from the spot rate curve. Now we're given in the question that this bond is fairly priced, and we're asked to compute the one discount rate, also known as the yield to maturity, that would make the present value of all these cash flows equal to this value that we compute here. So we set our present value as the price computed based on the spot rates. We know that we have 3 payments of $45 each and a final face value payment of $1,000. So we feed these values into our calculator and we get R, which is the yield to maturity on the bond, that is the single discount rate, as 2.986%. And for a bond equivalent basis answer, we multiply that by 2 and pick C as the correct answer. So this problem illustrates a very fundamental bond valuation principle, which is that essentially there are 2 ways to compute the present value of a bond. The more precise answer is when we discount each cash flow of the bond at the appropriate spot rate based on the timing of that cash flow. So the second, less precise way is when we take a single discount rate known as the yield to maturity and discount all of those cash flows with the same rate regardless of the timing of the cash flow. Now in the example we've just covered, we computed the present value based on the precise method, and then we computed the implied yield to maturity based on that value. Let's look at the next problem. Now here we're given a $1,000 face value 12% coupon bond with 20 years to maturity, and we're given its yield to maturity as well. And we're asked what would happen when the yield to maturity increases by 47 basis points. Pretty straightforward question. We compute first the present value given the 11% bond equivalent yield rate. Then we bump up the yield to maturity by 47 basis points or 0.47%. And we compute the present value with that as our discount rate. And finally, we work out the difference between those two values to get the change in value. Now remember, because the yield has gone up, the price has gone down, and the difference will be a negative number. In fact, it's minus $38.99, and B is the correct answer. Good luck with your prep as always, and I'll be back soon with more videos.